In South America lives a group of extraordinary animals. They are amongst the most spectacular creatures on Earth. They have fascinated us for as long as we've known of them. They are hummingbirds, and their glittering colours and their prowess in the air are unmatched. They are the celebrities, the stars of the bird world. But what do we know about these unique birds? Well, they are tiny, dwarfed by a scientist's hand, amongst the smallest warm-blooded animals on Earth. And we can see that they live their lives in the fast lane. In flight, they are just a blur. It's only when you slow down their supercharged lives that you can begin to understand how they live. High-speed cameras reduce the speed of the action. 1 second stretches out to 50 and enables us to look into the secret world of the hummingbird. Much of their lives still remains a mystery. What we do know is that hummingbirds depend on flowers for their food. Nectar fuels their frenetic lives. And that hummingbirds are only found in the New World. Most live in South America, and this is where our story starts. Here, many plants employ hummingbirds as messengers. But this wasn't the original contract. When flowers first evolved over 60 million years ago, there were no hummingbirds. The first flowering plants depended on insects as their pollinators. Today, many plants still do. As butterflies move from flower to flower, sipping nectar, they take pollen from one plant to another. The plants are fertilized, the insects are fed. This was the original arrangement. The plant and insect relationship has been a long and successful one. But at a certain point, some plants dropped their insect messengers. The reason can be found in the forested mountains of South America. Here the mornings are cold and damp. Butterflies can't fly in these conditions. Insects are cold-blooded. Their bodies are the same temperature as their surroundings, so they are lethargic in the cool of the morning. In the mountains, insects are unreliable messengers. There was a need for a safer pair of wings. We may never know for certain where this change of messengers took place, but somewhere in South America, perhaps on the ancient plateaus of Brazil, plants acquired a new partner. It probably happened about 50 million years ago. In the cool climate, plants needed a reliable messenger, and there was a bird that could fill that requirement. A bird that possibly looked like this saw-billed hermit found a new way of making a living. This ancestral hummingbird was most likely an insect and spider eater, its heavy bill adapted for grasping its prey. At some point, the earliest hummingbirds started visiting flowers. Did they do it to extract insects from the blossoms? Perhaps. But as soon as the habit developed, then the birds could carry pollen from flower to flower. And the first hummers could not only catch insects, but also drink the nectar. The original hummingbirds, with their heavy bills, were relatively large and rather clumsy flyers. But this was the beginning of a long relationship with the plants, and the birds evolved to better suit their new ways of life. Over millions of years, bills became lighter and thinner to better probe the flower for nectar. To reach the flowers demanded great flying prowess, and the early hummingbirds became smaller and more agile than their ancestors. As well as thin bills, the birds developed long tongues to probe the flowers and sip the nectar. Reaching the nectar demands a huge amount of energy, and so hummingbirds did everything to lower their weight. Their legs and feet became so small that they could no longer hop or walk, they could only perch. They were already leading an extreme way of life, living on an energy knife edge. For many millions of years, hummingbirds remained generalists, feeding from a wide variety of flowers. And many plants took up with the new pollinators. Today, there are over 8,000 different kinds that depend on the birds. But there was a penalty to the New Deal. The plants had to supply more food for their dependable warm-blooded messengers exactly for that reason. Warm-blooded birds used 10 times more energy than the cold-blooded insects they replaced. A hummingbird drinks more than its body weight in nectar each day, and hummingbird flowers produce a copious amount of liquid to suit their messengers. It was thought that hummingbird plants produced orange and red flowers to attract their messengers, but the story is more intriguing than that. Bees are red-green colorblind. The plants were hiding their precious nectar from these insect robbers that can't see the difference between red and green. Whilst making it obvious for their feathered couriers. The hummingbirds too paid a price. To further protect their nectar from insects, the plants made their flowers long and thin and placed them at the end of branches. Only an animal capable of precision flying could reach the flowers. Hummingbirds had to hover, and that cost a great deal of energy. Input, high-energy food, but to obtain it demands high-energy output. Hummingbirds were forced into a precarious energy balancing act. Holding perfect position in space is a hummingbird trademark. No other birds can do it. Though the similar-sized banana quit does try. But in truth, compared to a hummingbird, other birds look clumsy. The reason is the way hummingbirds fly. All birds, except hummingbirds and swifts, their distant relatives, gain power and lift on the downstroke, then fold the wings for the upstroke and repeat. Hummingbirds keep their wings stiff and do not fold them. Instead, they rotate at the shoulder so that the wing twists, giving lift and power on both strokes. The extra power gives the hummingbirds a great advantage, and they can claim to be the most accomplished flyers that have ever taken to the air. Their special mode of flying gives the hummingbirds the power to maneuver in all sorts of ways. Unique among birds, they can fly backwards. They can rotate on the spot, even fly backwards and upside down. The plants, with their hard-to-reach flowers, had produced the ultimate aerial acrobats. All this virtuosity in the air costs energy. When flying, hummingbirds have the highest oxygen demand of all vertebrates. Wings beat as fast as 80 times a second. The problem is getting oxygen to the flight muscles. When the bird is perched, the heart beats around 400 times a minute. In flight, it rises to an astonishing 1,200 beats per minute as the heart pumps oxygen-rich blood to the wing muscles. Even this is not enough when hovering, and so the heart expands in size so it can pump more blood with each beat. When this happens, the blood circulates around the whole body, heart to lungs, to heart to muscles, and back to the heart in under 1 second. They're living at the edge of what is possible. Extreme aerial athletes with extreme needs. It's no surprise that when they're not flying and feeding, they rest and conserve energy. Hummingbirds spend 80% of the day perched, and so they have time to stretch muscles and groom all-important feathers. Showers provide another opportunity to clean and brush up feathers. Unlike insects, hummingbirds seem to relish the rain. So when the skies open, the minute birds take to the leaves to bathe. Even a banana quit joins in. But bathing can only be a short interlude, for hummingbirds need to feed on average every 15 minutes. Starvation, death, is only ever a matter of hours away. It's essential for birds with such a precarious energy balance not to waste time visiting flowers that contain no nectar. But is it possible that hummingbirds can remember all the flowers they've just recently visited? This might appear straightforward when you have only a few flowers on a stem. But what about when you face the task in an ipe tree? Even here, hummingbirds can and do remember the flowers they've visited, a great feat for a bird brain. Plants have certainly shaped hummingbirds, their size, their powers of flight and hyperactive metabolism, but the birds can't live by nectar alone. They need protein, and this they catch on the wing with the most remarkable precision and aerobatic skill. Not all flights are successful, but most are. The birds need the protein to build muscles and replace feathers. The only problem is avoiding choking on the tickly little flies. Hummingbirds are unique in many ways, but they share with all other birds the need to breed. The male wire-crested thorntail has a bizarre way of impressing a female. Its courtship lasts a matter of seconds and was unnoticed until the high-speed camera revealed its unusual nature. For a bird living on a knife edge, the display appears an extravagant flaunting of energy. And it may be designed to do just that, to show off the male's fitness. Despite all his energetic endeavours, this female remains unimpressed. It's the female alone that builds the nest and tends the eggs. But for hummingbirds, even this is not straightforward. To remain on the nest long enough to keep her eggs warm, counterintuitively, the female has to lower her body temperature. Only in this way can she reduce the time needed to spend away on feeding. The most dangerous time in a hummingbird's life is when it's a chick. They must stay inconspicuous. Only when the down feathers on their backs detect the downdraft of their mother's wings will they silently beg. The chicks are fed a rich mix of nectar, pollen and insects. But despite all this attention, few nestlings reach adulthood. Even as adults, hummingbirds face severe problems. They have to refuel with nectar every 15 minutes. So how do they survive the hours of darkness? Every night of their lives, hummingbirds face a challenge: to stay alive until the morning. Their answer is as extraordinary as every other aspect of their lives. They go into torpor, a kind of hibernation. Their body temperature plummets, heart rate drops from 400 to 40, and they consume 1/100th of the energy they use when flying. This is a truly radical and dangerous solution, for whilst in torpor they can't move. There's no possibility of escape from a nocturnal predator that might find them. As day approaches, they start to shiver and warm up. It may take half an hour before they return to normal. Only by these extreme measures can hummingbirds survive to greet another day. Living an extreme, hyper-energetic life as they do, hummingbirds must ensure they have a supply of nectar. For most hummingbirds, this means guarding a patch of flowers large enough to support them. The flowers are a bird's lifeline. So even when it visits a plant to feed, a hummingbird keeps a wary eye out for possible nectar thieves, like this female thorntail. Most trespassers, when confronted by the rightful owner, back off and leave the territory. But in the main, owners defend their patch of flowers by the most flamboyant display of colour. Hummingbird feathers are extravagantly iridescent. The colours are not produced by pigments, but by layers of microscopic air bubbles in the feathers. The air bubbles refract, reflect and recombine sunlight to produce dazzling colours. The colours depend on the angle of sunlight, so hummingbirds can switch on and off their brilliant signals, flashing a warning to an intruder, but able to hide from an enemy. If the warning flash of colour fails, then a hummingbird will fight. Although tiny, they're not delicate tropical gems, but aggressive combatants. It's a matter of life and death. An owner must defend its precious supply of nectar. The aerial battles are really a fight for flowers, for without a territory, most hummingbirds are in deadly trouble. In northern Brazil, there are even temporary territories that last just a matter of hours. The cactuses that colonize the bare rock only reveal their flowers in the afternoon. In the morning, they're hidden inside these strange caps, and the rock garden is deserted. But when the flowers open, then hummingbirds appear as if by magic. They remember when the nectar becomes available. The birds feast on the copious nectar and in return carry away the plant's sticky pollen on their bills and pass it on to other flowers. The hummers carve up this miniature world, patrolling their airspace and chasing off interlopers. The temporary rulers of the cactus patch are fearless. They attack each other and ignore a lizard far bigger than themselves. But when it comes to bees and wasps, they retreat. Hummingbirds are too small to risk being stung. It would be fatal. The hummers stay and feed and fight and guard their prickly patch until evening. Then, as the light fades, they gradually slip away, to return next afternoon. Hummingbirds, with their remarkable adaptations, were an evolutionary success. They moved into a variety of habitats, wherever there were flowers that needed reliable pollinators. And about 17 million years ago, another opportunity arose as the Andes, pushed up by the drifting continents, grew ever higher. The volcanic Sierra reached up to over 5,000 meters, higher than the ancestral Brazilian plateau, creating new habitats. The mountains also brought new challenges. There was less oxygen at these dizzy heights, and the air is thinner, less dense. Some plants offered their feathered messengers support. The shining sunbeam clings to the fuchsia while it feeds, and so saves the high cost of hovering. Other birds found a different way to cope with life in the high mountains. The giant hummingbird has huge wings. The extra wing area makes up for the thin air. And the giant sweeps its wings in a vast arc to create more lift, the wingtips nearly meeting at the end of each stroke. The giant is the biggest of all hummingbirds. It's the same weight as a great tit, and perhaps this is the upper limit for hummingbirds. The Andes, with their wide range of habitats, produced an explosion of hummingbird species. Half of all the kinds of hummingbirds live in these mountains, along with their plant partners. And a few plants formed a closer relationship with their sexual messengers. This is angel's trumpet, and its flowers are enormous, 20 centimetres long. The nectar is produced at the far end of the tube, out of reach of most hummingbirds. This coronet simply doesn't have the means of reaching the nectar. Only one bird can sip from the angel's trumpet. This one, the swordbill. Its bill is actually longer than its body. It has the longest bill, relative to body, of any bird in the world. And that remarkable beak and equally long tongue allows the swordbill to feed where no other bird can. And a big bill can have other uses. The angel's trumpet is not the only plant to form an intimate bond with the swordbill. This is a kind of passion flower, and it too has a long tubular flower. The orange on the swordbill's chin is pollen. Each time it drinks from the passion flower, pollen is transferred back and forth between plant and bird. By forming this close liaison, the passion flower and the angel's trumpet increase the chances of their pollen being successfully transferred to a plant of the same kind. And the hummingbird has the nectar of the plants all to itself, so both plant and bird benefit. There's another hummingbird that has formed an even closer relationship. It has an exclusive deal with this heliconia. The heliconia protects its yellow flowers inside robust red bracts. The flowers are deeply curved. Only this bird can reach the nectar. Its bill perfectly matches the curve of the flower, like a key in a lock. As it feeds at its private flower garden, pollen is dabbed onto its head. The bird transfers the pollen from one plant to another, ensuring successful pollination. Because the sicklebill has the heliconia nectar all to itself, it has no need to defend a territory. Instead, it spends its day flying from one clump of flowers to another. And not needing to display its ownership of flowers, the sicklebill is not iridescent. Rather, it's quite dull, camouflaged against its exclusive flowers. The next chapter in hummingbird evolution was written about 6 million years ago. Some hummingbirds became even smaller. These micro hummingbirds are amongst the smallest warm-blooded creatures on Earth. They weigh as little as 2 grams, the same as a single penny, and they compete directly with the insects. They're not only smaller than other hummingbirds, they look dissimilar and they behave differently. Their flight is more like an insect's, as they roam freely through the forests, feeding on a variety of flowers. The mystery is why the tiny hummers, like this wood star, are not attacked by the bigger territory owners. The aggressive emerald ignores this little thief. Why? More mysterious still, the miniature wood star shows no fear at all as it plunders the emerald's nectar store. It might be that the emerald doesn't recognize the tiny wood star as a hummingbird. Rather, its small size and insect-like flight fools the bigger bird. The emerald even shares a flower with a little sneak. Could it be that the wood star is trading on the hummingbird's inbuilt fear of wasps and bees? This new group of micro-hummingbirds may have originated in Central America. From there, they've spread far to the north. The draw was flowers. But there is one major drawback to living so far north: winter. So each autumn, ruby-throated hummingbirds must head south before the flowers die and leave them without food. By September, they arrive in places like Rockport, Texas. Some may have already flown over 3,000 kilometres from Canada, but many still face their greatest challenge. They must continue south, and for some that means crossing the vastness of the sea. The local people put out feeders to help the migrating hummingbirds. Each arriving hummingbird feeds furiously. They must gain weight, converting sugar-rich nectar into fat. In just 3 days, a bird will almost double its weight. This is the equivalent of a human of average weight putting on over 50 kilos of fat. Once the birds have put on enough fat, they move the short distance to the coast. The time has arrived for the greatest test of their powers of flight. The nighttime journey, at least 800 kilometres non-stop, is an enormous undertaking for such tiny birds. A last sip, and the birds set off across the Gulf of Mexico. Much about the journey remains unknown, but recently scientists have tracked the birds using the Doppler radar of the United States National Weather Service. Designed to discover water droplets inside clouds, this sophisticated radar can also reveal the path of flocks of small birds, including hummers. Once they're beyond the range of the radar, their journey is shrouded in mystery. There is much we still do not know about hummingbirds, about their secret high-speed lives. But what we do know is that they are the most remarkable, colourful, energetic and acrobatic of all creatures. They live at the limits of what is possible, nature's miniature masterpieces, and all because they are the messengers of plants.